Sign analysis is used to solve the problem of building sign, including sign distance, sign time, and sign area, and the relationship between light and shadow of building facades. Sign analysis method mainly include calculation method, graphic method, and computer-aided analysis at sector. First, a stick-shadow method is introduced. Stick-shadow chart describes the laws of the sun's movement based on the relationship between the height of the stick at a point on the ground and the length of its shadow. Trajectory of the sun is respected by the trajectory of the endpoint of the stick shadow created by the stick in direct sunlight. Let's take a look at these two pictures. Picture A reflects the relationship between the stick and shadow, and picture B reflects the basic principle of the stick-shadow sun picture. A straight rod OA with a height of h is erected at point O on the ground. When the sun's latitude angle is hs, the sun just hits point A at the top of the rod. The shadow formed by point A on the ground is marked as point A prime. The shadow is the line segment OA prime, and the shadow length is h prime. Then the relationship between N, the rod, and the shadow can be expressed by the relational formula that h prime is equal to h times the cosine of the sun's latitude angle. When the cotangent of the sun's latitude angle is constant, h prime is proportional to h. Set h as unit height, then the unit shadow length is h prime. Then the shadow length of different building heights can be obtained. Using this relationship, the variation range of stick shadow for a day can be obtained. This is the bar shadow trajectory diagram of the spring equinox and autumn equinox. As can be seen from the figure, the shadows of point A at the top of the bar at 10 o'clock, 12 o'clock, and 14 o'clock are A10 prime, A12 prime, A14 prime respectively. The line connecting the 3 points respects the stick shadow trajectory of the 3 times unit height from 10 o'clock to 14 o'clock. Similarly, the stick shadow trajectory of each unit height can be obtained. The radial line respects the azimuth line of the shadow of the rod at a certain moment. At the angle with due source is azimuth angle of the rod shadow. A10 and A14 marked in the figure respect the azimuth angle of the sun at 10 o'clock and 14 o'clock, which is equal to 180 degree minus the rod shadow azimuth angle. Line segments OA10 prime, OA12 prime, and OA14 prime respect the rod shadow length at 10, 12, and 14 o'clock respectively, and also respect the corresponding timelines. These contents constitute the rod shadow solar chart, with respects to contents. One is S prime and AS prime of the straight rod located at the observation point at a certain moment, and the other is HS and AS at a certain moment. This is a stick shadow chart of the winter solstice in Guangzhou with latitude, season date, scale, and north direction. Let's take a look at the application of a stick shadow chart. This is a flat roof building with a height of 20 meters, a concave plane, and an opening facing north in the area of 40 degrees north latitude. It is required to use the stick shadow chart to find the shadow area on the ground around 10 a.m. on the summer solstice. First, draw the building plan on the transparent sulfuric acid paper and cover it on the stick shadow chart, so that point A of the building outline coincides with point O of the stick shadow chart, and at the same time ensure that the compass directions of the two drawings are constant. The scale of the plane is 1/500th and the scale of the stick shadow is 1/100th. The height of the stick is 1 centimeter, represent 5 meters. The height of the point A of the building is 20 meters. Then take point A prime at 4 centimeters of the ring at 10 o'clock in the stick saddle chart, and A prime is the saddle length at A. Using the same method, place the points B, C, E, F, and C double prime on the point O of the stick saddle chart in order to obtain the saddle length, and collect them in sequence to obtain the saddle error. Using stick saddle chart, you can also find indoor sun error, building spacing, orientation, sun time, seat size, etc. It is very inconvenient to use a lot of stick saddle charts. Now you can use sun software more, and you can learn it by yourself. Let's take a look at the calculation method. The residential building spacing is divided into frontal and side spacing, and the general residential spacing refers to the frontal spacing. This is the formula for calculating the solar spacing and the solar spacing factor. In the formula, D is the sun distance, and LO is the sun distance coefficient. HO is calculated height of the front building, which is equal to the height of the front building minus the height of the bottom, still of the rear building. R is the difference between the rear building azimuth and the sun azimuth. HS is the sun elevation angle. Next, let's do an exercise. It is known that there are two front and rear buildings facing the source on a flat site in Shanghai, each with a height of 18 meters. It is required that the ground floor of the Great Cold Days gets 2 hours full window sunshine before and afternoon, and the height of the window is still 1.2 meters. Find the building spacing and the sunshine spacing coefficient. It can be seen from the Shanghai air that the altitude is equal to 31 degrees 10 minutes, and the declination angle is equal to minus 20 degrees from the Great Cold Day. It is 2 hours before and afternoon from 11 to 13 o'clock. Since the sun latitude at 11 o'clock and 13 o'clock is the same, the absolute value of the solar azimuth angle and the hour angle are the same, with opposite signs. Calculated at 13 o'clock, the hour angle is equal to 15 degrees. The idea of solving this problem is to first calculate the sun's latitude and azimuth, and then calculate the insolation distance and the insolation distance coefficient. Bring the above data into the calculation formula in the previous lecture. The sun latitude angle is equal to 36 degrees 94 meters, and the sun azimuth angle is equal to 17 degrees 39 meters. The sun spacing is equal to 21.4 meters. The solar spacing factor is equal to 1.27. You can use the calculation method to check whether the building spacing of the school building meets the sunshine standard, and then try the school building in another location. You can also check whether your architectural design work meets the sunshine standard. Think about the reasons why the same large sets adopt different floor spacing in different locations. What happens if the building is not facing due source?